Good day, student. For DC biasing amplifier circuit using PNP transistor, I did not discuss because it is not involved in your test and final exam. This circuit also using PNP transistor, so that I did not discuss because it is not involved in your test and final exam. This is also not involved in your test and final exam. Transistor hints and tips. All transistor current IB, IC, and IE must be positive value. Second, IE equal to IB plus IC, so that IE is equal to 1 plus beta IB. And then current IB must be in microampere, and then current IC almost the same as IE, and the unit is in milliampere. For design operation, I did not discuss because it is not involved in your test and final exam. I'm also not discuss this example because it is not involved in your test and final exam. This is also not involved in your test and final exam. I'm also not discuss example 4.14 because it is not involved in your test and final exam. This is also not involved in your test and final exam. EC and small signal component. In electronic circuit, the input signal can be divided into two types, that is DC component plus VCC, and then AC small signal component, that is VIT. The DC component signal is not a function of time, where it is constant and fixed and always same all the times. For example, VCC equal to plus 20 volt and VCE equal to plus 8 volt. The small signal component VIT is a function of time, where it is an AC signal which is always changed in time. Then the signal VIT is referred as SV small signal component because its magnitude is generally small for all time. For example, the voltage divider biasing amplifier circuit, this is the input voltage, that is the AC signal. This one is the output voltage VO, which is also an AC signal. From capacitor C1 until capacitor C2, the signal is AC and DC. For example, for voltage VB, this is the AC signal, and then VBQ is the DC signal. And then voltage VCE, this is the AC signal, and then VCEQ is the DC signal. The purpose of DC analysis is to find the Q point of transistor BJT, that is current IBQ and current ICQ and voltage VCEQ. The Q point must be in the active region, so that the AC signal does not go into saturation and cut off region when it is applied. The purpose of AC analysis is to obtain the voltage gain AV, which is VO over VI, current gain AI, power gain AP, input impedance ZI, input impedance ZO. In this topic, we only focus the voltage gain AV, and then input impedance ZI and output impedance ZO. The SC analysis of BJT will be continued in part 2.